Come light it up, I'm ready to go. Come light it up, come light it up, I'm ready to go. Come light it up.
Hi everyone, I'm Lakshmi Mohan, pronounced she, her. I'm a director of engineering at Slack. I've been at Slack for nearly 4 years. I live in Cupertino, home to several parks and trails with my husband and 2 kids. And with me, I have Sharon.
Hey folks, I'm Sharon, pronouns she, her. I am a new addition to Slack. I've been here less than 6 months. I'm in the data infrastructure team and been doing all kinds of data stuff for more than a decade. I live in San Francisco with my husband, my son, and my dog. So excited to present here.
Great, let's jump in. Today, we are here to talk about data engineering at Slack. We'll give you an overview, introduce our culture and architecture, and leave you with some key takeaways. At Data Engineering in Slack, our vision is to make data-informed decisions a breeze. Imagine having insights at your fingertips, making smarter choices, and getting things done faster. By providing intuitive tools, accessible data, and comprehensive support, we aim to empower users at all levels to harness the power of data to find answers in seconds, make decisions with confidence, and level up their productivity. As the stewards of Slack's data ecosystem, we provide the foundation for data-informed insights and innovation. Our data lake serves as a central hub for analytical workloads. We enable teams across the organization to access, analyze, and leverage data to make informed decisions. As Slack has scaled, so has our data lake to keep up with this growth. Comparing to 2015, our robust and scalable data platform processes 1,000 times more data. It drives efficiency with 80 times more pipelines, and it stores about 8,000 times more rows and enables 100% more users to uncover valuable insights and fuel business growth. Aren't these numbers amazing? So how is all this data consumed? Our data is utilized by various teams and stakeholders across the organization. Data is consumed for exploration, advanced reporting, and analysis. Engineers create dashboards to track key metrics, measure performance, and inform decision-making. Engineering managers establish KPIs to align their team's work with company goals and objectives. Data scientists track the usage and adoption of Slack tools and services. It is used for experimentation and A/B testing. Product leaders leverage data-driven experimentation and A/B testing to optimize product features and user experiences. It's used for business operations. Our data powers critical business processes and revenue analysis using our billing and usage datasets. It's also used for product development. Our data is leveraged to derive data insights to inform the development of new features and feature improvements. It also provides data-driven support to enterprise customers and administrators. People come to Slack for its cutting-edge technology and exciting challenges, but they stay for the incredible people and culture. Slack's core values are smart, humble, hardworking, and collaboration. These are the foundation of our success. These values guide our work and create a positive and productive environment. Let me dive into all of these a little bit more. We are customer-centric via measurable KPIs. We are the data team after all, so we have prioritized delivering value to our customers in a data-informed manner. We have developed a comprehensive set of input and output metrics to define and measure KPIs. This has proven tremendously useful to plan and guide our focus areas and investments for continuous improvements. This has helped us identify gaps and improve areas such as timely data delivery, ensuring Data is accessible at the start of customers' workday, enhancing productivity. Operational efficiency. We are committed to striking a balance between developing exciting new features and optimizing our engineering practices for efficiency and cost effectiveness. Our focus on reducing and cleaning up unnecessary data has significantly improved our data efficiency and reduced costs. We continue to deliver innovative features while maintaining a strong focus on engineering best practices. Empathy. We prioritize empathy and understanding in all interactions with our customers and stakeholders. We do this in several ways, notably by responding promptly and effectively to customer issues, demonstrating empathy and commitment to resolution. By providing a seamless and supportive onboarding experiences for new employees, and by fostering a productive and learning-focused environment for summer interns. Majority of our former interns have published blogs about their positive experiences and learnings in data engineering, and they have come back as full-time employees. Knowledge sharing and collaboration. We encourage knowledge sharing through mentorship programs and regular training sessions. Some examples are our data learning program and lightning talks. We have over a library of over 200 lightning talks now. We provide comprehensive documentation and resources to support tool usage and learning. We also have forums and ERGs for engineers to exchange ideas, collaborate on projects, and foster innovation. We encourage experimentation and prototyping to drive innovation and explore new possibilities. Our team regularly participates in Slack days. Several of these initial prototypes have grown to be generally available for all users. Some have grown to a scale that we have created teams around them to continue to maintain and improve them. By embracing all of these values, we have cultivated a culture of continuous learning and collaboration. This empowers our team to stay ahead of the curve and deliver exceptional results. With that, I'll hand it over to Sharon to talk about our architecture, design principles, and some of our exciting big bets.
Thanks, Lakshmi, and thanks for setting the stage regarding our vision and culture so beautifully. So now diving into the architecture. First, I want to ask you, have you heard of Maslow's hierarchy of needs? So Maslow was an American psychologist who first came up with this idea of hierarchy of needs, ranging from basic needs to self-actualization needs. Self-actualization needs are met when one achieves their true potential for personal growth. The idea is that basic needs need to be met first before one can have everything they need to achieve their true potential. In data, we have a similar construct, in my opinion. In the data world of Maslow's hierarchy of data needs, everything starts with like the basic plumbing and wiring that is required for ingesting logs and raw data, for building pipelines and moving data through ETL, and then using all of this to build and publish metrics and gold standard insights. Only once these basic building blocks are in place can teams like AI, ML, and data science and search can achieve their true potential, and through them, the company. And for us within data engineering, our focus is on the bottom 3 layers of that pyramid. We want to build a very robust platform that provides all of this plumbing and wiring and excellent data sets that can help the company achieve its true potential. At a bird's eye view, this is what our architecture looks like. Agreed, this is a much simplified version. There are many components that I haven't displayed over here, but I'll walk you through at a high level how we think about the lay of the land. So at a high level, it's divided into ingestion, processing, and storage. We ingest raw events and raw data in the form of events, logs, and change data from databases. Most of these ingested events are schematized using Thrift. And we have both streaming-based as well as point-in-time recovery-based systems in place for ingesting this change data and also events. On the processing side, we offer a range of options. Most of the data movement and ETL jobs are written in Spark using Spark SQL. But the reason why we have so many range of options is because we want to meet different latency needs, different use cases, and different throughput needs, and so on. Starburst Trino forms the backbone of all analytics, dashboards, ad hoc queries, everything, all the metrics and insights that people are looking at. We also offer Pino for our external facing data analytics for our Slack business customers. On the streaming side, we mainly use Kafka for data movement and Kafka Connect for processing. In fact, most of our ingestion pipelines are also moving towards a more real-time data ingestion using Kafka Connect. We are also currently running a proof of concept for Flink for our use cases that require more complex stateful aggregations and where latency is important. On the storage side, we store all our data in S3 in Parquet format and provide Hive and Iceberg as metadata catalogs. Hive has been around for many years. It is our legacy catalog, and we are moving towards Iceberg, and we are in the thick of that migration as we speak. The metadata itself is stored in a hosted Hive metastore, and we use Apache Ranger, not pictured, along with Hive metastore for fine-grained access control, which is also hosted on-prem from open source Apache Ranger. Spanning ingestion, processing, and storage is our data governance and discovery layer that is constantly ingesting metadata from these systems so that we have a full picture of how data is moving, lineage, ownership, and all of that important useful information. On the user plane, we have a variety of ways in which users interact with these systems. For visualization, we support two offerings. So we have ATS, which is a homegrown visualization software. And we also have Tableau, we recently started supporting Tableau, which provides really rich visualizations. Jupyter notebooks are really popular for development, for testing. It's very popular among data scientists. And Airflow is typically used for scheduling workflows and for data movement. Next, I would like to discuss some design principles that we really focus on and keep in mind as we evolve our architecture. And we use them as guiding principles. And it's not just within data engineering, but it's used Slack-wide. The first one is don't make me think. As Lakshmi mentioned earlier, customer empathy is a big focus for us. We want to make sure that our customers are able to focus on their business problems without having to worry about all the nitty-gritties that don't matter to them. And for that, we strive to provide rich, easy-to-use abstractions and self-serve tooling that hides away those complexities. And we strive to provide those abstractions at every layer, not just for our external customers, but for our internal customers, which is like rest of the data engineering team. To give you an example, we have multiple Starburst Trino clusters, but they are all hidden behind a Trino gateway proxy. The gateway proxy allows us to route traffic away from unhealthy clusters when needed or during upgrades, and it also helps perform green-blue deploys, etc., without affecting our customers. And Trino Gateway also provides some interesting things like stat-spaced routing so that we can utilize our clusters more efficiently. On the external-facing customer side, we all can appreciate that getting core metrics right and preventing proliferation of duplicate tables and metrics is very hard. Moreover, writing Spark jobs is not as simple as just writing a SQL. You have to think about configuration and scheduling, so many other things. To abstract all that away, the team at Slack built Merlin. Merlin is a metrics framework, which is a declarative system that allows users to define metrics using SQL queries with templated start and end dates. Merlin supports the creation of wide tables with various dimensions, enabling quick queries on detailed datasets. It also abstracts away the configuration parameters sent to Spark, allowing users to stay focused on their business problem. Users can write the query once, and Merlin decides how to schedule it, how to partition it, when to run backfills, and so on. The second design principle is prototype the path. We like to borrow from the wisdom of our peers and try to use vetted open source technologies as much as possible instead of reinventing the wheel. In doing that, we again practice humility and don't presume ourselves to be so smart that we can't learn from the wisdom of the group. If you pay close attention to our architecture diagram, you will notice that except for one, which is ATS, which is a home, our Slack, a data visualization tool built at Slack, everything else is either open source or widely used across the industry. Trino, Spark, Pino, Flink, Kafka. Then we have S3, Tableau, which are not open source per se, but they are widely used. And the goal here is to use vetted technologies that are tried and tested. ATS, which is the one of the only ones that are built in-house, have existed for a long time. And it came at a time when there were very few similar visualization tools which provided the same feature set. And it has served us really well. The third principle is to seek the steepest part of the utility curve. Or in other words, we heavily use data to determine technical investments with high ROI. There is a huge emphasis on data-driven prioritization. And one such project is Project Cobbler. And I love this name. One of my brilliant teammates came up with this name. There's an old Spanish proverb that goes, the cobbler's children have no shoes. We in data engineering provide rich data and metrics to the rest of the organization and our customers. But before Project Cobbler, we didn't have any insights for our internal services and systems. Project Cobbler solves that by providing metrics about on-time performance, service performance, cost attribution, SLOs, etc. We have also started an org-wide push towards formally measuring toil. Toil, as you know, is more of an internal-facing metric and affects velocity. It can lead to burnout. It can affect efficiency and so many other things. And we want to make sure that we are tracking that and prioritizing projects that minimize toil and help us move fast efficiently. We also recently launched an effort to formalize SLOs for all our systems and services so that we can be more methodical about deployments, rollouts, and measure investments against their impact on these predetermined SLOs. We are also tracking operational and service health through metrics such as number of alerts and pages, time spent on toil, escalations, incidents, etc. And we have started doing a monthly review of these. The last principle is to take bigger, bolder bets. We strive to maintain a healthy balance between following the paved path while taking big bets or the route less traveled if the perceived return is high. And here are some big bets that we are investing in or thinking about. As Lakshmi touched upon earlier in her slides, the one a task that our team or an organization really cares about is making sure that older unused data sets are cleaned up, we have effective retention policies so that we are managing cost really well. To serve all of that, we are thinking about providing storage as a service and abstraction over our data warehouse to manage retention, attribution, for governance, for managing permissions, providing easy to use self-service tooling. The other big push is to make sure that our offerings are ready to serve the next evolution in technology, which is AI. Every company, including ours, is moving in that direction with a lot of initiatives, and we want to make sure that our data offerings are ready to handle that. So in keeping with that, we have been thinking about prototyping Ray. We have been prototyping PySpark. We are thinking about Flink for some of the low latency use cases. The next is Iceberg. As you probably most of you know, Iceberg has been very popular. It has been gaining in popularity over the last couple of years, and we are also making a strong push towards that. Then comes containerization. So today, our Spark runs in Elastic MapReduce, AWS's EMR or Elastic MapReduce clusters, which are multi-tenant clusters. And we want to move towards a containerized world for isolation, for better version management and so on. And the team has been working very hard to build a first version of Spark on Kubernetes. Then richer visualization tools. We recently started, adopting Tableau across the board. Data Hub, there's a lot of work that has been done towards data discovery and governance, cataloging metadata from all the systems. And then building a modern self-serve user plane. We are constantly focused on building better abstractions, faster deployment, always thinking about how can we serve our users better. Next, we'd like to talk about some takeaways from our side, but I'm sure you might have other takeaways and we would love to hear from you. So to kick it off, as we built this, our big focus, as you must have noticed throughout this theme, our big focus has been customer. We are a very customer-centric organization and very data-driven. So whenever we are making investments, we think about how is that serving our external or internal customers. And the next is striking a healthy balance between innovation and operational excellence. How can we make sure that our current systems don't deteriorate while also making room and resources for taking big bets? And Lakshmi has more to add to this, so I'll hand it over to her.
Thank you, Sharon, for that awesome overview of our architecture and design principles. It got me super excited. A few key takeaways that I want to add from my side as well. Cultivating a culture of innovation and collaboration. We have gone to great lengths to foster a very collaborative environment where teams work together to achieve a shared goal. It is very common to see working groups consisting of members from different teams, roles, front-end, back-end engineers, data scientists, to come together and create a shared vision and roadmap for implementation. This enables us to take different perspectives into consideration and drive clarity to large, ambiguous, open-ended projects. By encouraging calculated risks, we drive innovation and break new ground. We also prioritize ongoing learning and development to stay ahead of the curve. Leverage existing solutions. The Slack platform naturally lends itself to open, transparent communication and knowledge sharing. This readily available information enables us to identify and leverage existing tools and frameworks whenever possible to avoid redundant efforts. And finally, abstraction for efficiency. We break down silos and promote data sharing through abstraction layers, streamline workflows, and thereby reducing complexity as a whole. By embracing these principles, we create a more efficient, innovative, and collaborative work environment. In closing, we hope this overview has provided valuable insights into our daily work, our team culture, and our approach to architecture and design. We also hope this inspires you to create a positive and collaborative work environment where innovation and excellence thrive and commit to data-informed decision-making and continuous improvement. Thank you.
Thank you.